Hi, this is Ahed from Logos Learning, and in today's video, I will be talking about how to solve exponential equations. Now, exponential equations are equations in which the variables appear as exponents. If you take a look at this first equation here, our variable x appears as the exponent, so this is an exponential equation. Now, to solve exponential equations, we have to keep in mind this one important property. If base a to the power of x is equal to base a to the power of y, then the exponents can be equated. X is equal to y. Here a cannot equal to 1, 0, or -1 because if it took any of these three values, this property would not be valid. Now let's take a look at the first example here. 4 to the power of x plus 1 equal to 2 to the power of x minus 1. Are the bases identical? No, they are not. But we know that 4 is a power of 2. We know that 2 squared is equal to 4. So we can replace the 4 by 2 squared. 2 squared to the power, so 4 to the power of x plus 1 is equal to 2 to the power of x minus 1. Now, if we use the power law, here we can multiply the exponents. So 2 to the power of 2 to the times x plus 1 is equal to 2 to the power of x minus 1. Now, are the bases identical? Yes, they are. So we can equate the exponents. So 2 to the power of x plus 1 is equal to x minus 1. We can multiply the 2 into the bracket. So we have 2x plus 2 is equal to x minus 1. We're going to bring all the x's to one side. 2x minus x, it's positive here, so when we bring it over, it becomes negative, is equal to -1. Positive 2 here becomes -2 on the other side. 2x minus x is equal to x is equal to -1 minus 2 is -3, and we have the solution to our exponential equation. X is equal to -3. You can verify that. You can pause the video and verify that. Just sub in -3 for each x and see if both sides of the equation are equal. Let's do another example. In this equation here, 9 to the power of 3 plus 3x plus 1 is equal to 27 to the power of x. Our bases are not identical. Now, is 27 a power of 9? It isn't. But we know that both 9 and 27 are powers of 3. Because we know that 3 to the power of 1 is 3. 3 to the power of 2 is 9. And 3 to the power of 3, you said it, 27. Very good. Now, we're going to rewrite 9 as 3 squared. And that is to the power of 3x plus 1. And 27, we're going to rewrite it as 3 cubed to the power of x. We're going to do the same thing here. 3 to the power of 2 times 3x plus 1 is equal to 3 to the power of 3x. Now, we can equate the exponents since we have identical bases. 2 to the power of 3x plus 1 is equal to 3x. We're going to multiply the 2 into the brackets, so 6x plus 2 is equal to 3x. We're going to bring the 3x over and to the other side, so 6x minus 3x is equal to -2. 3x is equal to -2, and we divide both sides by 3. X is equal to -2 over 3, and this is the solution to our exponential equation. Now, in this next equation, we have another type of problem in which we can factor something out. So here, 3 to the power of x plus 2 is 3 to the power of x times 3 to the power of 2. Because if you remember the multiplication rule, a to the power of m times a to the power of n is equal to a to the power of m plus n. So here we went the reverse way. Now, 3x times 3 to the power of 2 minus 3 to the power of x is equal to 216. Now, if we take a look at this, we have two terms, this term and this other term. What do they have in common? That's right, 3x. So we're going to take it out as a common factor. 3 to the power of x, and what we have left here is 3 squared, and what we have left here is negative 1, is equal to 216. Now this is easy. 3 to the power of x, 3 squared is 9, minus 1 is 8, is equal to 216. Now let's get rid of the 8 here. Divide by 8, divide by 8. 3 to the power of x is equal to 216 divided by 8, which is 27. Now we don't have the same base, right? So we're going to try to get a base of 3. 3x equal to 3 cubed. Now the bases are identical, so we have x is equal to 3. Well, ugly 3, but you get the point. I hope this makes sense. Let's do one more example like this. 2 to the power of x plus 2, 2 to the power minus 2 to the power of x plus 5 is equal to negative 7. So again, I'm going to rewrite it in this form. So 2 to the power of x times 2 to the power of 2 minus 2 to the power of x times 2 to the power of 5 is equal to negative 7. Again, we have two terms. The common thing between them is 2 to the power of x, which I will take out. So we're left here with 2 squared minus 2 to the power of 5 equal to negative 7. Now, 2 to the power of x. 2 squared is 4. 2 to the power of 5 is 32. Is equal to negative 7. So if we just take it step by step, it's not so complicated. 4 minus 32 is minus 28 is equal to negative 7. So we're going to divide both sides by negative 28. This cancels out. 2 to the power of x is equal to, this becomes positive, 1 over 4. Oh my goodness, what are we going to do now? Now, if you remember my older videos, you will be okay. So 4, like we said earlier, is 2 squared, right? But we don't want the base to be in the denominator. We want to bring it to the numerator because here our base is in the numerator. So 2 to the power of x is equal to 2 to the power of negative 2. Now the bases are identical. We can equate the exponents, negative 2. So x is equal to negative 2, and that is the solution to our problem.